Hello everyone, today we're going to solve set 9, problems 15 and 16. Problem 15. How many of these four expressions are perfect squares? Now, we have four equations in total. And the first one is 1 cubed plus 2 cubed, which is 1 plus 8, and that is 9. And that is 3 squared. So this equation is a perfect square. Second one is 1 cubed plus 2 cubed plus 3 cubed. So it's same as 9, which is the first two cubes. 9 plus 27 is equal to 36, and that is 6 squared. So this equation is also perfect square. The third one is 36 plus 4 cubed, which is equal to 64, and when we add up, that is 100, and that is 10 squared. So the third equation is also a perfect square. Now the last one, we have 100 plus 5 cubed, which is 125, and if we add them up, we get 225, and that is 15 squared. So all four equations are perfect squares. So D is the correct answer. Problem 16. Each of the 9 small squares in this grid can be colored completely black or completely white. What is the largest number of squares that can be colored black so that the design created has rotational symmetry of order 2, but no lines of symmetry? Now, here, the center square does not affect the symmetries of the design, so we can just color the center circle in any cases. And to have a coloring which has a rotational symmetry of order 2, the pairs, each pair of opposite squares, that is the pairs labeled A, B, C, and D in the diagram must be the same color. And if we color all the tiles in black, then we have a lot of symmetry, lines of symmetry. Like we can have this vertical line, or this horizontal line, or this diagonal line. So it has a line of symmetry, so we cannot color all the tiles. So what if we color only one pair of tile in white? Then we have, let's say we just colored A in white. Then we have B, C, and D, and the center square in black. However, we have a diagonal line of symmetry, so this case does not work. And so we'll try with coloring B as white. So we have something H here, like an H. However, the vertical line is the line of symmetry, so B also cannot work. C and D are the same as coloring white, A and B as white, so we're just going to skip that. So we're going to make two pairs of squares as white. So I'm just going to do A and B as white. A and B as white. Then C and D should be colored in black. Now in this case, there's no axis, there's no line of symmetry. So there are total 5 tiles, 5 squares colored in black. So D is the correct answer. Thank you everyone, and I'll see you again. Bye.